Alright, so this is our fraction, and it has a radical in the denominator. But because we have two terms, we can't use our standard method, which is this. Because if we do, and we distribute, because there's a parenthesis there, you get 2 square root of 7 minus, and then that one would break open and say 7. But see, the radical's still there? It would be a never-ending battle. So what we have to use is a thing called the conjugate. And what it is if you look at it, you have a minus, now it's a plus. It's a plus, now it's a minus. So what you do is if it's a subtraction, you multiply by its conjugate, which is the addition form. And if it was an addition, you'd use a subtraction. So now watch what happens. We distribute. And when we multiply the bottom, we get 2 minus radical 7. 2 plus radical 7, so that's 4. It's 2 radical 7 minus 2 radical 7, and then radical 7 is going to give us 7 because we would have a pair and a minus. Look at the middle two terms right there. It's 2 radical 7s, take away 2 radical 7s. They cancel, and this is why we use the conjugate. In the middle, we're going to get the same thing, but opposite. 1 minus, 1 plus. And that's why we need that minus and plus. So they'll cancel. So what we're left with is 4 minus 7, which is minus 3. And this is why I didn't distribute. See how we can still cancel? So you always want to hold off on it, because sometimes you can cancel. Don't forget the negative. So they don't make 1, they make negative 1. Which gives us negative 2 minus radical 7. And that's rationalizing a denominator using a conjugate. See, this is much nicer looking than that. So when we multiply by the conjugate, the opposite, it'll cancel the middle two terms, leaving us with just a rational number for the denominator. Let's try it again. So the conjugate here would be radical x plus radical z. And then you have to do it to the top as well. So we get radical x minus radical z, and then radical x plus radical z. So when we multiply it, that comes out. Those both stay in, and then we get the minus form of it as well. And then that comes out. Okay, so now again, middle terms cancel. And we're left with x minus z, and then radical z, radical x plus radical z. Now nothing cancels, so we can distribute to give us radical xz plus, and then that will bring a z out. And that's it. Let's do one more. Alright, so the conjugate here, let me do this one in green. The conjugate here, because remember this is what we're trying to rationalize, would be square root of 5 minus square root of 2. Okay, so on the bottom, square root of 5, square root of 2, square root of 5, minus square root of 2. And honestly, you know the middle two are always going to cancel, but that's 5, and that's minus 2. So we know we're going to get 3 for the denominator, because this will always cancel. Alright, so on the top, we've got to FOIL that one as well. So square root of 7, square root of 5, square root of 5, minus square root of 2. So that would be 35 minus 14. That would be 5, and minus radical 10. No like terms, no pairs to simplify. So we get square root of 35 minus square root of 14 plus 5 minus square root of 10. And that is the final answer. So again, we use the conjugate to cancel off all the radicals, because where the radical appears is in the middle terms. And if we do the opposite sign, they will cancel. It's a nice little trick. Thank you.